Hello, my name is Rafał Biegacz. I'm working for Google, where on a daily basis working on Cloud Composer, which is a managed service for Airflow. And today I have a pleasure to talk to you about how to run Airflow on Kubernetes, either using Cloud Composer or community-baked Airflow Helm chart. So before we get to the nitty-gritty details of how to run Airflow on Kubernetes, let's maybe focus on what actually Kubernetes is. So Kubernetes is a distributed platform for running distributed systems. And it was built according to the modern software deployment paradigms, like infrastructure as a code. It has capabilities that allow you to auto heal and auto upgrade your application. So it's a very modern platform that is very popular nowadays. You can run it anywhere in your private data center. You can go to a public cloud and you can do self-managed Kubernetes, or you can use one of the managed services that deliver Kubernetes to you. What it promises to you is no vendor locking. It's an open source technology, and it's part of Cloud Native Computing Foundation initiative. Cloud Native Computing Foundation organization ran a survey in 2021 when they asked many questions related to Kubernetes and other technologies to the users. And one important data point from the survey is that 96% of the users either already use Kubernetes or they are planning to do that. So as you can see, no doubt Kubernetes is very popular. Okay, so now let's maybe talk about Kubernetes in the context of Airflow. There are different ways of running Airflow. You can use virtual machines. You can also again use Kubernetes, and there are some other methods to run Airflow. Airflow community ran a survey in 2020 when they asked what's the most popular way of running Airflow when it comes to Airflow users. And as you can see on the right-hand side, that Kubernetes and virtual machines are the most popular methods of hosting Airflow environments. If you would like to learn more about the survey results and especially more how to Airflow is running on Kubernetes, you can also go and find Airflow Summit 2021 presentation called Airflow Loves Kubernetes, which has plenty of information. Now let's talk about how to run Airflow on Kubernetes, and this part of today's talk will be consisting of two phases. First, we will run Airflow on Kubernetes, and then we will focus on Kubernetes features that are very attractive very beneficial for Airflow. I'm going to cover two ways of running Airflow on Kubernetes. So first, we'll focus on using Apache Airflow Helm chart. And in the second step, we are going to take a look how you can use Cloud Composer to run Airflow environment on Kubernetes. What is actually a Helm? Helm is a package manager for Kubernetes, one of the most popular package managers for Kubernetes. And again, this is a project that is part of Cloud Native Computing Foundation. And Helm allows you to package all the parameters required to run your application in the form of charts. So Airflow community prepared a dedicated Airflow Helm charts for Apache Airflow, so you can easily run Airflow on Kubernetes in a few steps, and we will see in a moment how easy it is. So first of all, we need to have a Kubernetes cluster. So for example, in case of Google Cloud Platform, you can navigate to Google Cloud Console, which is a user interface for that you can use to create resources in Google Cloud Platform. With a very few steps, you can, using user interface, you can create a cluster. After you provide some initial parameters, within a couple of minutes, the cluster will be created for you. If you prefer to use some other way of creating Kubernetes cluster, like for example, some command line and the gcloud, there is a way to open a Cloud Shell on GCP Cloud Console where you can enter your commands and cluster will be created for you. Once we have the cluster, now we can focus on configuring Airflow so it runs on Kubernetes. So again, in GCP Cloud Console, you can navigate to Cloud Shell. Within the Cloud Shell, you will have already Helm installed. So to be able to proceed with the installation of Airflow, you need to add Apache Airflow repository to Helm. Once you do that, in the second step, you need to run a Helm update command. Then the next two commands that are presented in the screen are related to definition of needed variables, release name and release namespace. In the fifth step, you are going to create a namespace on Kubernetes cluster within which all Airflow components will be running. And the last step in this procedure, this is using Helm actually to execute all the commands from Apache Airflow chart. And again, once you initiate this command, within a couple of minutes, you will have a fully blown Airflow environment. Maybe just one disclaimer. When you use Apache Airflow Helm chart, with default parameters, you are going to create an Airflow environment that is very good for testing out, but maybe not for production usages. Of course, it is possible to use Helm chart to create production deployments. There is even a special guide created for you. The link to this guide is presented in the slide. You can navigate to this page and learn what default parameters of Helm chart should be changed to get a production grade Airflow installation. Okay, now let's take a look how we can run Airflow environment using Cloud Composer. Again, we can navigate to Google Cloud Console to the user interface. Once you enable Composer API, you will be presented with a Composer user interface page. On this page, you will be able to find the Create button. Once you click it, you will be able to see that you can select Cloud Composer, one of the two Cloud Composer versions. My recommendation to you is to use Composer 2 version, which provides to you auto-scaling and by default uses Airflow 2. If you don't need to tune anything in the Airflow environment, the only actually required parameter here is the name of your Composer environment. Once you click Create button, Airflow environment will be created within several minutes for you. So in this particular case, we used user interface to create Composer environment, but of course there are other methods that you can use to create such an environment. So you can use gcloud, you can use Directly API, you can use Terraform. There are also Python and Java clients, so you can create Composer environments in a programmatic way. And also there are Airflow operators for Cloud Composer. So from within other Airflow environment, you can create Airflow environments based on Cloud Composer. Now, when we have Airflow environment running within Kubernetes, we can talk more about Kubernetes features that are so beneficial for Airflow. One very important piece of information that you need to know as a person responsible for running Airflow on Kubernetes is that the smallest deployable unit of work on Kubernetes is called pod. Usually you define usually you use YAML files to define how a given pod should be configured by Kubernetes. Within a pod, you can run one container or many containers. Additional assumption that Kubernetes makes when you run pods on Kubernetes is such pods can be restarted anytime. This is how Kubernetes works. And of course, when running a distributed complex system, some of the components of the system might be stateless. So restarting is not going to harm or do anything wrong to your system. On the other hand, some other elements of the system might be stateful. It means that after the restart, the component needs to restore its previous data. And Kubernetes provides to you a method of adjusting your needs and map your needs into the workload types that it delivers. So on this slide, I provided a list of components from Airflow environments. On the right-hand side, you can see Airflow components as they are configured by Cloud Composer. On the left-hand side, you can see components that I configured for you using Helm chart approach. And you can see that, for example, a queue that stores Airflow task, Airflow Redis, is here configured as a stateful set, which is a signal for Kubernetes that this component needs to preserve its state even though it is restarted. On the other hand, Airflow Scheduler is a stateless component. It can be restarted. That's why we can use deployment workload type. And Kubernetes knows that if this component is restarted, our system is going to continue operate correctly. So one highlight from this slide to all of us is that Kubernetes provides workload types to adjust definition of our workloads to the needs of the components that Airflow needs to run. Another very interesting feature of Kubernetes is Kubernetes services. We already mentioned that pods, which are the smallest deployable units of work on Kubernetes, they can be restarted anytime. As a result of it, such a pod can be assigned a different IP address. On the other hand, if you are running a distributed system on Kubernetes cluster, the components of the system, they need to know how to talk to each other. So for example, Airflow worker needs to know the IP address of Redis queue. Because this Redis pod can be restarted anytime and it can get a different IP address every time, it wouldn't work for Airflow worker. And here Kubernetes services come into play because these are the entities that can be assigned IP addresses for good. And even if pods are restarted, you will still be able to talk to Redis service, which is going to pass the traffic to the actual pod that fulfills a given function. One additional feature of Kubernetes services is that it can load balance the traffic between more than two pods. So for example, if you come to a conclusion that you need more web servers to be able to handle more users in your Airflow environment, you can have many Airflow web server pods sitting behind web server service. And in this way, you are going to increase the capacity of your system. So one important highlight from when it comes to this feature is that Kubernetes services give you this feature of having a permanent endpoint to the components of Airflow environment. Another very interesting feature that Kubernetes offers to you is Kubernetes secrets. So in any distributed system like Airflow, definitely you have parameters that are sensitive and they should not be exposed in a clear text to, for example, users or other components. And here Kubernetes secrets come into play because you can store all those sensitive parameters in secret vault, where those parameters will be encrypted. And they will never be exposed to users or Kubernetes pods in a clear text. When a given component needs the given parameter, they can contact Kubernetes secrets, read it out from there, and they don't need to even store this parameter within the process space. One example of such a parameter that is very sensitive is Fernet key, which is an encryption key for encrypting connections. So as you can see on my right hand side, where there is a list of secrets, that Fernet key is stored in Kubernetes configuration as a secret in encrypted form. So this example comes from the configuration from Apache Airflow Helm chart on a very similar basis. Cloud Composer stores also secrets using Kubernetes secrets. Another very interesting feature that Kubernetes offers to is autoscaling. Autoscaling features are characteristic to specific Kubernetes offering or configuration. That's why I'm going to focus on Google Kubernetes Engine, which is a managed service for Kubernetes offered to you by Google. So Google offers three types of autoscalers for you: horizontal pod autoscaler, a cluster autoscaler, and vertical pod autoscaler. So those autoscalers are used depending on the need of auto scaling. So for example, if your cluster needs more or less nodes in the cluster, cluster autoscaler is going to take care of this task. On this slide, let's maybe focus on the horizontal pod autoscaler. Cloud Composer and Helm-based Airflow installation uses horizontal pod autoscaling to control how many Airflow workers you are going to have in your configuration. The way it works is if you have a lot of Airflow tasks to be executed, you can ask horizontal pod autoscaler to create more Airflow workers. So those tasks are executed as quickly as it is possible. Once you have smaller number of Airflow tasks in the queue, the number of workers can be scaled down. So in general, the concept in case of Cloud Composer and Helm-based Airflow approach are very similar. There is a dedicated metric that is maintained by special components. In case of Cloud Composer, this component is called custom metrics stack driver adapter. In case of the Helm chart offered to you by the community, there is a component called Kubernetes event-driven autoscaling. Those components are maintaining metrics. This metric is actuating horizontal pod autoscaling, and horizontal pod autoscaler makes a decision, okay, I need to add more Airflow workers, or for example, I can remove some workers to save some additional resources. Another interesting feature of Kubernetes are probes, and this is the way or means for Composer to discover if your components of your system running on Kubernetes are healthy. So there is so-called startup probe, and this probe tells Kubernetes whether your component, for example, once it was restarted, whether it already finished initialization. If it didn't finish, Kubernetes know that it needs to wait until the initialization is finalized. Once the initialization is finished, we can use a so-called readiness probe to be able to validate or evaluate whether Kubernetes can start sending traffic to a given component. So, for example, you remember that one of the things that we discussed that, for example, we could have a Kubernetes service for web servers and two pods behind this service. And Kubernetes will wait until readiness probes gives green light to it before it starts sending traffic to Airflow web server pod. Once the initialization is finished and Kubernetes confirmed that the component is ready for accepting the traffic, here comes liveness probe. And this probe is used to pass the information to Kubernetes about the healthiness of the component. So, for example, you could try to discover deadlocks that make scheduler not working properly. Or if Airflow worker is not able to execute tasks, you could also discover it. As a result of it, Kubernetes, once it gets a signal, okay, this component, it doesn't work as expected, it can restart it, and in this way, auto heal it. So for example, Apache Airflow Helm chart delivered to you by community gives you the possibility to use liveness probe for scheduler. And this liveness probe validates whether scheduler can create tasks. And if it can, it means that it can add tasks to the queue, and executor can pass tasks for execution to workers. On the other hand, if scheduler cannot fulfill this duty, it's a signal for Kubernetes. Okay, there might be something wrong with scheduler. Maybe I can restart it, and maybe it's going to help and auto heal the situation. When it comes to Cloud Composer, Cloud Composer uses liveness probes for all the components. And here in this slide, you can see a snippet of the configuration of Airflow Worker. Here you can see actually that Airflow Worker has a special file called Worker Checker, a Python file within which you have a program that validates the healthiness of Airflow Worker. One of the health checks that is done within this Python program is, for example, validation that Airflow Worker can pick up tasks from the queue. And of course, again, if the worker checker passes the information to Kubernetes, everything is okay. Kubernetes does not need to do anything. If worker checker discovers problems, it can gives a signal to Kubernetes to restart the component, and in this way auto heal the component. So in summary, as you can see, Kubernetes and Airflow married together. Kubernetes is a very rich platform, and it has a lot of features to offer to Airflow. So Airflow it can be run in a reliable and scalable way on Kubernetes clusters. The features that we focused today on is declarative way of defining components and adjusting workload types to the needs of those components. We can use auto scaling and auto healing capabilities to expand or shrink down the cluster to adjust it to the current needs of Airflow configuration, and we can use probes to auto heal the components. Kubernetes services are used to load balance the traffic and provide a means of providing permanent endpoints for Airflow components. And Kubernetes secrets, this is the way of storing the parameters of Airflow in a very secure way, in the encrypted way. In this way, Airflow configuration is much safer. With that, we came to the end of this presentation. I hope that you enjoyed. I recommend to you trying out Airflow, either by using Cloud Composer or using Apache Airflow Helm chart that is provided to you by Airflow community. If you need to find me, here's my Twitter account. Feel free to drop me a question if you have any. Thank you.